Hi, my name is Dave Redder. I've been a professor at Ohio Northern University for 38 years. I'm now retired. I developed this course design patterns for our computer science majors, and now I want to make it available to everybody at a different version. I mean, the online version is certainly not going to be the same as a 15-week class, but these ideas are very important to software developers, and I would like to give you an opportunity to learn these in much the same way that my students have over the years. The difference being, of course, that there's no homework, there's no quizzes, there's no in-class presentations, there's no in-class discussion, but I'm going to try my best to give you the opportunity to learn design patterns on your own, to the extent that you'll be able to use them to improve your software development skills. So let's move on with this. A design pattern is a named thing. It's got a name. It's object-oriented. It's a best practices solution, and it's a solution to a common software development problem. Now, each one of those words is seriously important, so I want to talk about each one for just a second. It's named so we can refer to it, and we tend to refer to these in our development efforts to other developers to say, well, that's just the observer pattern, or let's use a proxy to do this. And those are all patterns that were created, named and defined by the people that wrote this design patterns book you see on the screen, and that's Gamma, Helms, Johnson, and Felicities. And they have a really great attitude about this, and there are several reasons that it's titled what it is, Elements of Reusable Object-Oriented Software. The object-oriented part of it is that we know that object orientation is a valid and valuable way to think about software development to allow us to have flexible, modular, reusable, and understandable code. Flexible meaning that we can mess with it a little bit, and we can modify it, and we'll have still the ability to have code that we are confident in. Modular allows us to have pieces that are related or not related in separate places where we can maintain them separately, we can develop them separately, we can replace one without replacing the other. Those are some ideas that have been around for a long time. Object-oriented programming techniques have assisted in that for many years now. Object orientation started in the 1960s, actually. We want to have reusable code. Reusable meaning that it's something that we could have for this application and use it just as it stands for some other application, or maybe take it and modify it a bit for some other application. So reusability is even a piece of the title of this book, and it's an important piece of what we get out of having design patterns. But to top it off, it all has to be understandable. If it's not understandable by the author, if it's not understandable by the reader or some other user that's using, a developer that's using it, then it really loses a lot of its value. So object orientation really does improve our ability to take advantage of all of those kinds of features that we've been kind of searching for decades. The best practices part is very well described in this book. Best practices means this is pretty much the best way we know how to do this thing, or one of the best ways we know how to do something. But in the book, they talk about how many best practices solutions have come because people have been working on the problem for decades, years and years and years. And initial efforts may have failed, they may have sort of succeeded, but not very well. People may have improved on them for various reasons through the years, and as a result, we end up with something that evolves into what we now know to be the best way that we have so far, and it will continue to evolve. And so a best practices solution may or may not stick for a long time, but the ones that are in this design patterns book seem to be ones that are very fundamental to software development, and that these problems have been coming up for a long time, and that these solve it very well. I'm not saying that you can't improve on them, but I am saying that these are very good base solutions for some very important problems that we deal with. And then in terms of what a solution is, we'll see the answer to that as we go. I'm not going to give you a definition for solution now, but that pretty much gives you a definition of what a design pattern is as far as this course is concerned. The book specifies in its preface that this other little deal right here, it says design patterns describe simple and elegant solutions to specific problems in object-oriented software design. And that's a really nice way to say what design patterns do for us. It doesn't really tell us what they are so much as this other half, but it really does tell us what they're about. Simple and elegant solutions, and that's an important part for all software design. In the course, I'll use the following tools. You may want to have them too. You may or may not need them. You really are going to need a computer. I'm just using an old Dell Studio XPS computer that I've had for quite a while, and it does me just fine. I'm not using a lot of high-powered tools to make these videos or to make these course materials up, but I am going to use the lowest end software that I can get away with, partly because it's cheaper that way for you, and in this case, most everything here, I think everything here is free, but also because if I use some high-class piece of software that's got way more features in it than I need, it's going to get me confused, and you're going to have a hard time finding out where I went to do certain things. I'll try my best to tell you every time how to get from ground zero to the thing that we're discussing. The Visual Studio Community Edition, if you've got a higher edition, that's fine. It'll work just beautifully, is sufficient for this course. When you install it, if you haven't already, and if you haven't installed these features, you're going to need to go back and do that. But when you install it, you need to grab the desktop development environment for the .NET Framework, and that's under the workload section. And then I use MySQL, or I use it too, but I use SQL Server in the Microsoft environment. And if you just go click on the data storage and processing, you'll end up with SQL Server there, which we may not use at all in this coursework, but it's still convenient to have in that community edition. But then another thing that you could use in this course, if you were writing papers or trying to describe to someone else what you've done, is the Class Designer, which simply takes a class and describes it visually. It draws a picture of the class using a UML class diagram, and that's pretty convenient to have as well. And then I'm a big proponent of using the GitHub facilities. You got to have a GitHub account, and if you don't, get one. And I'm going to provide you all of the materials for this course that I make public through my GitHub repository, which is at github.com/d-redder. And there's not a lot out there right now at this recording. Then there will be more for this course, and there'll be some things for my classes and such as well. But everything that I have available to you will be here. And that'll include the code for the applications. It'll include some documents, and I'll show you what it includes here in a minute. But those are the tools that I'm going to use, and I expect that you'll probably want to use most of them as well. So maybe you should just go ahead and install these things if you haven't gotten them already, and be ready to hit the ground running. And then the videos. This is the center of the course. The centerpiece for the course is the video philosophy of training. And this, with videos, you can do the same kind of thing you do as when you read, by going back and rereading. You can backspace, you can go back in the video and you can pause it, and you do all these things, which is convenient. But also you get to see things happening in hopefully the same environment that you're looking at. And that sometimes makes things stick a little bit better. And so I'll be showing you, I'll write code live on the screen. I'll write code and then present it to you already written. You'll get a lot of different forms of this, but you'll be able to reproduce it. And if not, the code will be available anyway, whether you can reproduce it or not, actually, on my GitHub repository. So here's what the videos are going to be like. There are 23 Gang of 4 design patterns. That's the Gang of 4, those Gamma, Helm, Johnson, and Felicities. They're called the Gang of 4, or the GOF. And there are 23 design patterns in their book. First of all, let me mention that the book is is quite old for a computing textbook, a software development textbook, and I think is still useful if you want a book in your library. You can get a digital copy of it too. It's available on the Kindle and other forms. But the code that's in the book, some of it is Smalltalk, some of it's C++, and other kinds of languages in there, but the narrative in the book is really worth reading sometimes. So I would recommend, if you want to build your library of computing books, this is a classic, and this would be a good one to have on your shelf, whether it's a virtual shelf or what. So for each one of these design patterns, the 23 Gang of 4 patterns, I'm going to give a statement and a brief discussion of the Gang of 4's definition of the pattern. The Gang of 4 has specific definitions to say this pattern is for this purpose. This pattern allows us to solve this problem. And it's useful to look at the statement of it and then kind of tear it apart and decide what it's supposed to be saying and what we need to do to implement the pattern. And then I'm going to give you a demo of an application that uses the pattern to solve a problem. And it may be a software problem, it may not be a software problem, but it's always going to be a Windows Forms app that I build the pattern, and then I build an application around the pattern that uses the pattern to solve some problem. And then I'm going to walk you through the implementation. I'm going to show you the code, I'm going to show you the structure of the classes, I'm going to show you the relationships among the classes. We'll use a UML diagram to describe what the pattern looks like, and then I'll describe to you how to go about building it. Oftentimes what you'll do for this course is you'll build the pattern first and then come up with an application that uses it. And that sounds kind of backwards, but it really is not. Oftentimes we do that kind of thing. Sometimes I'll give you, I usually give you some uses of the pattern, some real honest to goodness real life kind of uses. But sometimes I'll give you some things to avoid as well, but where you got to be careful that you're using the pattern properly. And then we have some documents that will be available to you, and that'll again be on my GitHub repository. So that brings us to the end of this introductory video, and I hope that you'll take some time to look at the first one. The first one is going to be about the singleton pattern, which is a very simple pattern, but it's not as simple as it seems. All right. Thank you for listening.